Hey robot makers, hope you're having a good day so far. So do you want to build your own animatronic creation using Bottango, if I can get that out right, with no code? Then this is the show for you. So let's dive straight in. My name's Kevin. Come with the reason we build robots, bring them to life with code or no code, and have a whole lot of fun along the way. Okay, let's go over to today's show. Got a couple of show notes. Not too many notes today. We're going to get straight into the how-to demo. So what on earth is Bot-Tango? And it is kind of a portmanteau between bot and tango. It's software for building robots and animatronics. It's really, really cool software. So what are animatronics? Animatronics are electronically controlled puppets or figures designed to move and simulate realistic movement, often resembling humans, animals or human characters. And yeah, the word animatronic, I think Disney invented the term, and it's a portmanteau between animate and animatronic. And the first human or person animatronic was actually Abraham Lincoln, and that was at the Disney park. I can't remember which one it was, but yeah, 1960s. So been around for quite a while, and definitely used quite a lot in animatronics. Apparently the first animatronics on film was actually Mary Poppins. The little birds that they had were animatronic as well. So you can see Disney's got their names all over this. So where can you get Bottango from? If you head over to Bottango.com, you can download a copy for free. It's really great software. The fact that they give this away is absolutely awesome. You can actually support them by buying some of their creations, their models. We'll have a look at that in a moment or two as well, and you can see what you think. I'm going to make my own animatronic pet parrot, so you have to stay tuned for that one. This is going to be coming up in a couple of months time. So yeah, definitely go over to Bottango.com and grab yourself a copy. It works on Windows, Mac and Linux. So in fact, let me just do that now. We just head over to that site so you can actually see what this looks like. I'm just going to bring this up on a browser momentarily. Let me just get that closed out. And if I go down here, okay, so I'm over here on the Bottango website. You can see if you click on the animatronic software, it'll take you to the link. You can download it for free, and it works on Windows, Mac, Linux. Unfortunately, it doesn't work on Raspberry Pis, which is a bit of a disappointment. But yeah, you can see there they've got the little parrot robot being animated there as well. So that one is a kit that you can actually buy. So if we go to the animatronic kits and parts, this isn't sponsored by the way, so this is just software I've discovered that's pretty cool. So their latest kit's called Captain Cogbrow, and that's like a model that you put together. Maxwell is the little parrot. It's got a number of different servos in it, and it looks kind of very lifelike when you animate it with the software. And they've also got this little shield that you can put onto Arduino boards. This is very much an Arduino centric project as well. They also have merch pack, and they've got the Louis as well. So once you've downloaded the software, we can have a look and see what we can do with this. So I'm going to be using my InMove robot. So if you want to build a robot just like the one I'll be showcasing today, you can head over to inmove.fr. This is a French creation. It's really, really cool robot. You can 3D print all the parts and then just add some kind of hobbyist servos, similar to these kinds of ones, and larger. Some of the servos that this project requires are pretty huge, to be honest, but you can start with some of the smaller ones and build like a robotic hand, or in this case I've got a robotic head. You can just see just there waiting to be programmed. So if you want to build yourselves one of them, head over to inmove.fr and you can get all the files again for free. It's a pretty cool project. So if you like what I do and you want me to make more of these kinds of videos, please give this video a like. Drop me a comment, let me know if you've heard of Bottango before. If you use a different animatronic software, let me know what that is. I'd be very interested to know about that. And if you've not subscribed to the channel, please subscribe. It means so much to me that if when people subscribe or not, you can do what you like. And I do go live every single Sunday at 7 o'clock British summertime we're in now, so 7 o'clock BST. It can be GMT during the winter months, but this is daylight savings now, so we're over on BST. Cool. Okay, let's get over to how we put all this thing together. So what I'm going to do, I'm going to go over to me for a second, and I'm going to try and get the best angles of this. So I've got this robot here. It's got essentially two servos in it. One of them makes the eyes go side to side. The other one makes the eyes go up and down. Now, depending on how well behaved they're being today, I did notice one of them seemed to be acting up a little bit. So I'm just going to, I might need to do a bit of maintenance on it, but we'll see how it goes. So it is a little bit temperamental, this robot. And if I go to the overhead camera now, you can also see I have this little board over here. This is, I'm going to pull out the servos so that we can plug them in and see how all this works. And so this little board here, this is called a PCA 9685 board. So this little board, just see there, PCA 9685. And it's a 16-channel servo driver. So you put some external power in. I've just got a little desk power supply providing this with about 6 volts. And I've got a bunch of cables here that are going to be running over to an Arduino. So I've got a little Arduino clone. I'll just unplug this. You can see I've got a little Arduino Uno kind of clone. And this is just a regular Arduino Atmel kind of compatible one. So I'm going to plug that in, give that some power, and we're going to wire up this this robot. So it might be easier for me to do this on this camera here to kind of show you how this is kind of coming together. So on our Arduino, you've got all these different pins here, and there's some special pins on the very right hand side over here. Unfortunately the cable I'm using isn't very long on here, so it's not too easy to actually show you this, but the very two rightmost pins over here, these are labelled SCL and SDA. Let's try that on the overhead and see if that's any better. I'll just bring it up to the camera there. So you can see there it says SCL where my thumb is, and SDA. So that's the system clock and system data. We're going to be connecting up this board, the data and clock pins from the PC9685 board to those pins there. So I know that the blue is data and that the green is the clock. I'm also going to plug in the other little cables here. I've got the power that's running from the PC9685 board. So the very bottom, second to bottom pin is the voltage, and the very top pin is the ground. So they're going to go into the 5 volts and ground respectively. So we get this. This is the fiddly bit for me, trying to do this on the live stream. So there we go. Right, so the power lights come on. That tells me that this is now powered up. So the next thing I need to do is plug in my servo motors. So let's see which servo motor this one is. I'm going to plug this one into, if I get these the wrong way around, we can always rejig it, but it's going to be fine. So pin 0 and pin 1. So the way that these are labelled, there's 16 channels. The very first channel is channel 0, and then channel 1 all the way up to channel 15. So we're starting at pin 0 on there. So that is how we're going to wire up our robot, and you can see there he's not really doing very much at the moment. So what we need to do is head over to the Bottango software. So I've got this one installed. Let me just get it back to the kind of start page, and then I will show you what this looks like. Okay, let me head over to here. So this is the Bottango software. So once you've downloaded it, this is kind of what you're presented with. So the kits, if you bought one of the kits, they are a little bit pricey, the kits, but the software is free, so you pay your money, you take your choice. So if we look, for example, at this Maxwell, you've either got the instruction manual of how to put this robot kit together, so we can look at that one. I've just clicked on the revision 1 Maxwell, and you can see there I've already gone through this. So it kind of shows you how you would put this robot together one bit at a time. And it comes as a kind of a flat pat, laser cut parts, and it'll talk you through exactly how to put the robot together. So we're going to go back, we're going to assume that we've got our robot up and running, and we're going to do a brand new project. So let's start completely afresh. We've not got anything installed, and we're going to build up our in-move robot from scratch over here. So the first thing we need to do is add some parts. So I'm going to add a couple of servos. I'm going to add the very first servo, and I'm going to call this one eyes left right, because it's the servo that makes the eyes move left and right. And what we can actually do is tell this software that we're using the PCA9685 board, it just calls it I2C. So if I scroll up over here, we can see we're using the default driver, and we're gonna connect using the I2C and pin. So over at the top here, you can see we've got this hardware, and we've got this master and default driver. So what are these drivers? So the driver is essentially the Arduino. The Arduino is going to communicate between the servo driver and our computer. So I've got this running on my Mac here. So it just calls this default driver. You can see all the different ports down the right hand side there, and I've got this connected up via USB. So I'm just going to say connect via USB, and it's going to just find the USB, and you can see there the last time I connected this was on tty.usb serial-110. And if we want to actually flash our Arduino, we can simply just click on that button there, and this is going to upload the Bottango software onto our Arduino. So if we have an Arduino Uno, we can use that one. If we've got a Nano or a Mega, we can choose the others. Let's choose the Uno, and you'll see that it's really quick to upload the firmware. So it's actually flashing the firmware as we speak, and it's done. So you should see that turn green. We've now got that green light, which means the driver is up and running and communicating. So now that we've got that, we can then start working on our servos. So I'm going to go back to the build, and you can see there it says the servo is not live. So what I'm going to do, I'm going to click on make this live, and it says that there's an error. And that's because it hasn't got support. So let's see what we need to do there. It's probably just because I need to set up one of these extra settings on here. So let's there we go. We just need to switch the default driver on. So it's not enable support for the required external library. So what I'm going to do, I'm just going to reset the Arduino. I think it's because I've just flashed the firmware on it and it wasn't happy with that. So let's just do that again. Let me unplug it and plug it back in. Turn it off and on again. That's probably the best option there. And let me see if that's default driver. If we just go into the settings of that, just go into the drivers and just check everything's good there. There we go. Let's make that live. So the hardware driver has not enabled support for the required external library. Right. So if we scroll down over here. When we flash the driver software, which I did, if you remember, a couple of seconds ago, there was an option to include the PCA9685 driver, and we haven't included that. So what I need to do is reflash that. So let's do that again. Let's find the flashing firmware thing. What I might do is just delete this driver. Just click on the delete. And let's create a new driver on here. So let's see if we can do that. I'm going to basically just turn that off for now, and then I'm going to load that back up again. So I basically need to flash that firmware. So let's create driver. Let's select USB again. So this is going to be, yep, the Arduino. This is going to be USB, and let's find where we flash that button. Where's that disappeared to? So there's an option for us to actually include that. Master is not live, all drivers not live. Let's just delete that one. Okay, that's live. Master is not live, all drivers are disabled. So let's switch that on at the top there, see if that helps. Right, so what I'm going to do, I'm going to try and do that, re-upload the driver. There we go. So what I'd missed out was that option there to include the Adafruit PCA9685 PWM servo driver module. I don't know why they don't include that by default, but let's go ahead and do that. It's really quick to reflash. Phew, that was a hairy moment for a second. So you can see there that little spinny wheel tells me that it's now done that. Let's see if that's now up and running. Yep, that's all happy. I'm going to reset just by pressing on the little reset button on my Arduino. You'll see for a second it kind of goes off red and then it should come back on green, which is good. We can now go back to our build. we can now check and see, is this, so we want this servo to be live on project launch. Let's turn this on. I heard this servo move then. So what I'm going to try and do now is just get the camera. So let's just change that bench cam so that it's the other camera. Let's see, that should be, let's try USB camera. Nope, that's not the one. Let's try that one there. Right, okay, so I just want to be able to sort of see at the same time what's going on. So if I click over here, that's going to make, so this is the up and down eyes. As you can see, it's making the eyes look down and eyes look up. So down, up, and then kind of in the middle. So what I'm going to call that one then, instead of eyes left, right, I'm going to call this one eyes up, down. So if I go to the full screen again, eyes up, down, that's the name of the driver for this particular servo. So we want to add another one. Now what we could do in this kind of virtual environment is build a virtual model of our robot, but because this is like a face shape, it's really complicated to do that. It doesn't really actually add any value to the process what we're doing here, but you can actually add in cube cylinders, make joints with them so that they articulate. But in this case, I'm just adding the servos that we want to represent our robot. So if I just move that one to the right slightly, I can move both of them then by accident. There we go. I just want to show that there's actually two. So there's eyes up and down, and then the other one is eyes left and right. So I'm going to call this one eyes left and right. I'm going to scroll down and I'm going to find, yeah, let's make this one live on project launch. This one is also a I2C and pin, and this is on channel number 1. And we can actually make this one live. Now if we go back over to that sort of shared view there, and let's just move this. You can see one of the eyes is slightly misbehaving there. But you can see like the left eye is working fine, and then back to the middle. Now what you can do with these is you can adjust, if you want to bring the eye a little bit back, or you don't want it to turn quite so far, or on that one I can hear it sort of crunching a little bit, that looks fine. Let's go on that one all the way back, and then maybe push that a little bit further. Maybe the other way, let's see. So this is just adjusting, kind of fine-tuning just how far that goes. That's fine. Let's go back to the center. And again, we can also adjust that if we want to bring that so that it's looking ever so slightly more sort of front and center. So that's how we configure the minimum and maximum and then kind of default values. And we've then got, go back to this view here, we've then got 2 servos represented. Well, that's all well and good, but we can't do very much with that yet. What we want to be able to do is join these together to create a control, and then we can use that control to animate. If we went over to our animation panel over here, we could, if we wanted to, say the eyes up, we could create a new keyframe, and we could add a track for that eyes up and down. We could say that this is a joint track or a motor track, for example. So we could, if we wanted to, say this is the eyes up down, we could move that control. If I zoom in on that a little bit there, you can see you've got these little controls that change the position. And if we go back over there, as I move this, you can see that's the up and down. And we've also got the side to side there as well. So I could, if I wanted to, just move these around on the timeline. And if I move that there like that, and I'll go back and I play that animation, it'll play them like so. So there's a much easier way to control our robot, and that's using these pose targets. So what we'll do now, we'll go back to our build, and we're going to add some extra parts in here. So we're going to now move across on the very bottom of the screen there to get to these target poses. So a target pose, it has this little kind of crosshair thing that we can move around. Let's move that over. Let's move that up actually. This is going to be our eyes up and eyes down. So let's move that one to the top. So this is going to be the pose where we're looking up. So let's name this one eyes up. And let's then, if if I just move my little face out the way for a second, you can see we've got this edit pose. If I click on this edit pose, we can then say which pose we want to actually do. So if I just bring this back, we want the eyes to look up. So it's not that one, it's this one here. So we want the eyes to look up like that. Okay, so if I go back over here, I can then just make sure we've only got the eyes up and down pose. There we go. So I'm going to save that pose. And if I just click anywhere on that screen, that will reset the servos to that default position, because I could hear them straining a little bit there. Maybe we need to just dial it in and out a little bit. So we've now got this eyes up. If I click on that, that's going to make the eyes go up. So if I unselect that, look at the eyes. If I select it, you'll see that the eyes kind of look up. So if I select that again, if I just move this down, you might be able to see at the same time. So if I click on that, you'll see the eyes go up. And if I click away from it, the eyes will go back to the resting position. So that's great for eyes up. Let's do the same for eyes down. Let's do another pose target. Let's grab that pose target. And this time I'm going to have this one just physically representing in our workspace. One's up and one's down because it's kind of spatial that we're doing there. So this one is going to be eyes down. So let's call this one eyes down. And then we're going to edit the pose again. So we're going to grab our eyes up and down. I'm going to just move this over here so we can see there's the eyes down to the extreme right of that particular servo position. I'm going to save that pose. So now, if I now click just in the middle, the eyes are going to go to the center. If I click the top target, the eyes are going to look up. If I click the bottom one, the eyes are going to look down. And then again, if I just click to the middle, you can see those servos kind of animate on the screen. And you can also see that because there's a live connection, we're getting that real-time feedback. Okay, so let's now do some poses for the eyes left and eyes right. And then we can then put them into a control. So we're going to grab another pose target. This time we're going to move that one sort of over here somewhere. Let's go like that. Bring it up a little bit. And this is going to be eyes left. So I'm going to edit the pose. I'm going to add the eyes left right. And I think that's this one here. So if I now look at the same time as I move this, so I want these eyes to look left. There we go. That's about as left. Save that pose. And we're going to now create another pose target. So let's create a part again. This is the final pose target. And this one is going to be eyes right. Like so. We're going to edit the pose. We're going to add in our eyes left right. And I think, was it this one? Let's just go back to that split screen, and we want the eyes to look right. There we go. Save that pose. Okay, so we've now got, let me just move that in our little 3D space, just so it's kind of representing where it is in 3D space. So we've got these 4 pose targets now. So if I click on the top one, the eye's going to look to the very extreme up, look down, look left, and look right. Not sure why that other eye, I think maybe it's catching perhaps. Let's see if I do that, is that any better? Okay. So that's okay for the individual eye targets. We want to bring together a control where we can move anywhere up and down in two-dimensional space, and the eyes will kind of follow that through this control. So let's do that now. So I go back over here, let's add another part, which is going to be our pose blend. So this pose blend's come in here. It's this yellow looking control here. Now what we want to do is actually say that this is two-dimensional. So we've got these 2 dimensions here. And we want to add in some poses to this control. So I'm going to click on the Add Pose button. I'm going to start with the eyes up. So it's added this little dot here. Now I actually want that to be, in our control, I want that to be the very top. So if we look and see in this little dialog box here, the X position is kind of where it is. So if I change the X position to be 0, you'll see it goes to the left. If I have that halfway, so 0.5, that's to the middle, and if I have that as a 1, then it's going to go to the extreme other side. So we want it to be in the middle, but we want this Y position to be 1, so it's at the very top of the control. So let's add in another pose into here. So let's add another pose. Let's add the eyes down, and we want the eyes down to be Y position of 0. So we've now got that little target position there, and we've got that other position there, and these represent the poses. We can also add to this now, because this is a 2-dimensional control, the left and right. So let's add in to our target poses, let's add another, which is going to be our eyes left. So let's scroll that up. I'm just going to move me out the way there because I'm kind of blocking that control. And this time we're going to make this one 0, and that's in the correct place on this control. And we want to name this one as well. Let's just call this eye controller. And we want to have that final pose. Let's add in the eyes right. And that needs to be the Y of 0.5, but the X of 1. There we go. So that's now got the controls the way that we want them to be. So now if I just go back to here, let me just move this screen about a bit so that you can see what's going on. I'm just going to make this so we're looking at it straight on. If I move this little crosshair here around, what happens with the eyes? They're kind of now looking down to the right, down to the left, up to the left, up to the right. See, one of the eyes is really moving around and then the other one is not. I think there's something maybe wrong with that particular mechanism that should be pulling it around. I'll pull this apart in a second. You can actually see how this works in the background. But we've now created this controller, which means it's really easy to control our robot. We can make it look around just using this one control. So let's do something even cooler. Let me go back to full screen for a second. We'll now go to the animate panel at the top here. And look at this, it says live input control scheme. Let's click on that. And we can create a new control scheme. We can add a control. And what I'm going to add is I'm going to add in my Xbox controller. So once this is paired, I've already paired this with my Mac so that I can actually make this control this controller that we've created here, which is flashing away. So I'm going to select that one. I'm going to say that this is connected to the Xbox One controller, and we can have it automatically detect. So if I now use that control here, it's now got the X mapping, but we now need to add the Y mapping. So I'm going to, there's a little setting just behind my face there, so let's just move me out the way, add the axis binding, and again if I just select the controller, let it auto detect. So now I think I've got them the wrong way round, so I'm just going to swap them. So the X and the Y are actually the opposite way round, so let me remove them. So what I think I might do is just redo that, because I think I've got that wrong. Let's just add that back in. Let's add the eye controller. Let's find our Xbox. So this time we're going to start with auto detect. So that should be up. Let's try that, and then let's do the other axis. Let's see if I've got this correct this time. Nope, I messed that one up again. How did I do that, Kevin? So the X and then the Y. So the X is side, Y is up and down. I'll get this right in a second. Just bear with. Let's try that one more time. Add control, eye controller, Xbox. Now you can actually say that you want it to control with the left stick. We want the left stick X, and then let's add in the other binding. So Xbox controller, left stick Y. Yep, that's right, that's correct, that's working as I want it to. Okay, so I can practice now. If I now go kind of like this, and I show you the screen and the control at the same time. So I'm using this controller here. If I make that one go up, down, what's that? Left and right. So I can move that all the way around, and we're controlling this controller that we created, which maps to those servos. So we can now control this completely wirelessly with our Xbox controller. Now we can set up any number of servos, any number of controllers by using that same technique where we create the servo, we then create some poses, we then map those poses onto a controller, and then we can control that controller with something like a gamepad like this one. So Marie's asking a question there. Is this Arduino boards only? I believe so. I think it's if we go back to the hardware here, when we create a driver, let's go over here and create a new driver. You can only use, let's see if we've got, if they have a list of them. I think there's only like the Arduino, Uno Nano, and Mega. So yeah, I think it's quite tied to that ecosystem. I was really hoping this would work like with the full Raspberry Pi suite, but yeah, unfortunately not. So that's how you do that anyway. Cool, so let's switch that particular one off there. Okay, so now we can go back to our animator. Now we've got this controller, and we've actually got our game controller. It makes it a lot easier for us to add in our animations, because we can perform the animation using our control. So what we can say over here is, the input is going to be from our controller, which is that Xbox that we created. We can hit the record button, and we can, whatever performance we want to do with our controller and record that. So you can see there we've got a whole bunch of data points, and that's as I was hitting, and it will actually play those back if I do that. You can see they're the controls that I sent to it, and you can even limit how long this plays for just by moving this kind of playhead. So let's say it's only 4 seconds long, for example. Maybe it only starts after that there. There we go. So what do we do next with this then? So what we can do is we can either just have this always connected up to this software, and when we want the animations to play, we can just select what the animation is. So this one, so we could have, for example, an animation. Let's create an animation, and let's call it double take. So let's go to the settings on there. Let's call this one double take. Okay, and what we're going to do is make the eyes kind of go like that. So we can do this either by using the Xbox controller, or we can just manually use this controller that we've created on screen here. So let's move all the way back here. We're going to use our eye controller. We're going to add a track for the eye controller. So let's use our eye controller pose blend. You can see that if I use that little disclosure thing there, we've got these X and Y on our controller. So if we start position 0, that's fine. We can add in, as soon as we start moving this around, you can see that a little point appeared on our timeline, a little keyframe. So we can move that to say 1 second. We could then have the eyes look to the left, and then maybe go to 2 seconds, and then make them go to the middle. This is going to be very, very slow as a double take, and then we can make that go back like that. So if we now play that back, you'll see that the eyes kind of look and then do a double take. Maybe if we made them more extreme, so instead of going to the middle, which is that one there, we could actually make that go all the way across, and then back, and then to the center. So let's try that one. So because that's so slow, we could speed that up just by moving these points a bit closer together. So just like regular kind of animation, you can tweak this. So this is now going to take 2 seconds instead of 4 seconds. Let's try that. Kind of better. a little bit janky. Now, one of the reasons might be because the animation is very linear. It's just moving the servo to the position, and then, you know, if we want to add a bit more character, we can use this graph control. And this means if we zoom in on this, let's see if we can zoom in on that a little bit using that. Where's the zoom control on here? There we go, right. So what we can do on here, they have these little Bezier curves. So if we want to make a curve kind of happen quickly, we can use these controls to have a quick and then sharp stop. So let's go back and see what that one looks like. We can make that one so that it's it stops very quickly, but then starts slower, stops quickly, and then perhaps this is more of a ease in and ease out kind of thing. So let's see what that looks like. Still a bit slow, so maybe we can just move these up a bit like that. So that the green control, that's the kind of up and down. So we could probably get rid of any of these ones. So I think we just delete them like that. Oops, not the whole thing. Great, just deleted the whole thing. So we'd have to just recapture that. So we can just do that by going back in here, setting the eyes to the beginning. There we go. It's come back there. So we can now move that one back over there as well, again just so that it's a much quicker animation. So yes, once we've captured all these and we've tweaked the graph the way we want it to be, and again you can have any number of servos. I've just used 2 servos here. If we have the mouth servo, that could open and close, have a bit more expression. If he's got a neck, he could move left and right. If he's got some kind of tilt, and any number of things that can add expression to the robots, you know, that will only help. Okay, so now that we've got the data captured there, we can actually export this if we wanted to the Arduino, so that it doesn't have to be plugged in and always connected to a computer. It can just be the Arduino driving the servos. And it's quite interesting how this works. So you can see there we can select which of the animations we want to have. So I've got the default one and the double take. We can say what the drivers are to include, so the eyes up and eyes left, right, they're the servos. And what's the starting animation, so we could say maybe the double take one, and that we loop them so that they're continually doing this forever. And there we go. So that's going to, it says the Arduino Uno has 11,000 bytes of capacity, the Mega has 225,000. So the estimate of how much memory is required for this export, 3,000 bytes. So it's not very much. And we can decide how we want that to be stored. Either as just like driver code. Let's export that and see what actually happens. So I'm going to export that there. Yep, that overwrite existing code is fine. So what I'm going to do now, I'm going to head over to my computer's hard drive, and I'm going to find where that code lives. So I think it's in shows, and I think it's on Bottango. Yes, so if I now open up, let's move this to that window there. If I open up this here, you can see we've got this, how to use this code. So in order to use this generated code, you'll need to do 2 things. In the Bot-Tango Arduino folder, you'll find the Bot-Tango Arduino config.h. You'll need to uncomment the line in the file that has the definition use command stream. This tells the code to read the commands from the generated code instead of from your computer over USB. So although this is designed to be no code, there is this element here where you have to edit files. You have to be comfortable doing that. So we'll have to do this within the Arduino IDE. Then it says drag the 2 generated files, generated command streams.cpp and generated command streams.h into the Bot-Tango Arduino folder. Once you do these 2 things, re-upload the Arduino.ino file to your Arduino, go back to the live code, reverse the 2 steps to unload it to get back where you were. So you can see there we've got this generated command streams, and all that data that I input from the Xbox controller to tell the the servos to be at various different positions over that timeline. That's what this looks like here. It's basically just got a whole block of like hexadecimal code, which tells servos where to be at what particular time. So obviously the more servos that we have, the more data that this will be, and we might need to use something like an Arduino Mega, which has got a bit more RAM to be able to manage that. I do believe there are some limitations as well, so I think you can have, although that the PCA 9685 board has 16 channels, I understand that you can only control 8 servos at a time per Arduino, which seems a bit of a limitation, but it's more to do with the limitation of the working RAM rather than anything else. There we go. So that's the CPP. There's a H file as well, which is just the header file that tells it all the different functions. And then there's the this iTest was the name of the file that I created. So if I save this, I can give this a name like live stream demo, for example. If I go back to there, I've got the live stream demo.Bottango file extension. So it's quite a small file, and we've got the code there. It's even done an auto save there as well. We can import models if we want to, so there is this import where we can import music and video, or also models. To give you an example of what the music and the video can be, if I actually come out of this and go into Maxwell, let's have a look at let's do a new Maxwell project. So it's actually going to generate a whole project file for us, and you can see what I kind of professionally put together by the people who created this software. So let's actually come out of that. I'm going to hit the play button, and if I turn up the sound, so he's singing and synchronizing. I don't want to get copyright struck, so I'm going to stop that there. But you can see that he's singing, and that there's a video clip playing behind him. So if I go to that there, you can see, just turn that down a little bit, press play. You can see that he's kind of singing, and that there's a video clip playing behind him. So this is one of the models that you can actually buy. I'm actually generating my own version of this very robot that you'll be able to laser cut. So it's pretty cool, isn't it? You can see on there they've got a lot more things going on. We can actually go over to the build, and we can have a look and see how this works. So we've got things like there's a body, there's the head servos, they've got positions of those. You can actually see that working. Oh, it says it's not live, although I don't really know what that would do. We've not got that particular robot connected up. There's the joint for the head rotation. You can see that that's there. They have all the other body parts all connected together, and then they've also got these pose targets. So look center, look left full, look up, look down, look right. There's the video player, and there's also the head controller, which if we spin that round, we can see the head controller's there, very much like the one that we created. It's not very easy to maneuver around on here, that's the only thing I would say. I don't know if there's a sequence of keys I can use to make that zoom in a little bit easier. But yeah, so if I move that, I can move the robot around. You can see there his little chest cavities moving around. You can see that little servo horn just there that's also responding to this controller that they've created. So that's pretty cool, isn't it? He does also have wings as well. I don't know if they've got the wings hooked up on here. It doesn't appear that they have, but they have got this like learn how to. So there's lots of written tutorials. There's actually not too much video content out there for Bottango, and it says on here this is a setup. Learn how Bottango Studio works. You can just convert this to like a regular one. So yeah, I understand. And there we go. This is as if we've now built it. We can control all the different aspects of it. So there we go. So how cool is this? This is a Bottango. I really like this software. This is something I'll be looking to build more projects on in future. I'm thinking like Halloween type projects where we have like an animatronic. One of the things that we haven't looked at on here is triggers. So we could have something like a motion sensor, like an infrared sensor, and when that triggers, that will trigger an animation, and the animation will start. So the animation might be like, you know, the robot says something or jumps, you know, forwards if it's an animatronic ghost or something. So there's lots of things that we could do there using triggers. So the triggers are just another part. So if we go back to the build, create part, triggers are, if we go over here, see we've got these triggers here. So it allows you to have a custom event, but you do need to get into the code to use them. This isn't no code as I understand it. So there we go. So yeah, you can build your robot using these very simple structures, or you can import from a file if you've already got some kind of model created. So I think it tells you what kind of, so FBX and OBJ files. So if you've got it in Fusion 360, I think you can probably output as an OBJ file. I've not tried that myself yet, but there we go. That's how we use Bottango. Cool. Let me know what you think about that. Let me know if that's something you're interested in. It's free, give it a go. If you've got an Arduino lying around and a couple of hobby servos, you can set up a project yourself and start having a play with that. So this is where I pitch my little products. So let me find that gamepad controller that I was using last week. So this is a fully built gamepad 2 controller. This runs off the Raspberry Pi Pico W with the little controller there. Wi-Fi controller, and we also have the Robot Maker's Almanac and the Maker Notes as well. So the Robot Maker Almanac has all the pinouts. So if you have an Arduino and you want to know all the pinouts are for that, then we have a section on that. There's the Arduino Uno R3, tells you all the different pins. So we've got on there the I2C SCL, I2C SDA, the 2 pins that we looked at the very beginning of the video today. Probably just about make that out there. So they're all listed on there. And if you want to build a robot and you want to know what the physical dimensions of that particular board are, then we can find that on here as well. So let's find the Arduinos. All the Raspberry Pi ones are in there. There we go. So there's a page there, page 29. It's got all the Arduino dimensions on. So if you want to build 3D model or some kind of 3D printed case or enclosure, you've got everything there. So there we go, that's the Robot Maker's Almanac. The Maker Notes are simply blank but dotted paper, so you can make all your notes, all your drawings and sketches on there. So head over to kevsrobots.com, grab yourself one of those or one of these awesome gamepads to control your robot. We could have used this instead of the Xbox controller, because this also does work over Bluetooth too. Cool. So yes, if you want to join our Discord server, you can do that. Go over to Discord, kevsrobots.com/Discord, and you'll get a sign up link there. It just takes a couple of minutes to come through. That's Discord, not my server. And then you can join our free community there. So head over to there if you want to join the party. And if you want to follow me on social media, I'm on all the social medias. So on Threads, I'm at KevMcAleer at threads.net. On TikTok, I'm at KevMcAleer6. On Instagram, I'm at KevMcAleer. On X, I'm at KevsMac, and I'm also on Mastodon at KevsMac at Mastodon Social, and I'm also on Blue Sky at kevsmac.bsky.social as well. So yes, definitely check me out and follow and say hi. That's the main thing. Say hi. Share pictures of robots you're working on as well. If you want to get your name in the end credits, you'll find all the information about how to do that over at kevsrobots.com/coffee. We have a Buy Me a Coffee, and we also have the YouTube memberships as well, so you can decide how you want to do that. Maybe just a one-off coffee, or maybe you want to join the as a more long-term member. Whatever you find works best for you.